course. Let's restart and let's very briefly recap what we learned yesterday. We finalized the derivations, if you like, of these three equations, right? So that's where we spend our time on. The Newton-Phillips curve, the very first equation, and then the second equation, the IS curve, and then the Taylor rule, right? So those were the three building or key equations in the Newton, the standard Newton model. And then we familiarized ourselves with what is the transmission channel when monetary policy changes its policy. And so when the central bank unexpectedly reduces the nominal interest rate, how does that nominal interest rate change transmit into the economy? And we learned that that is really a very important element once you think about the Newton model, that it is the so-called real interest rate channel by which monetary policy changes or affects allocations in the economy. The idea is that it is the difference of the nominal interest rate minus expected inflation that's relevant for households' investments and savings decisions. That difference is what drives households' consumption demand. And the central bank affecting that demand for goods or desire to save, by changing the nominal rate, is only going to be affected when inflation is sticky, when the inflation is when prices don't adjust immediately. So in other words, when the central bank cuts the nominal rate and expected inflation doesn't move, extremely, then it can affect the real interest rate. And then we went through yesterday that kind of generates a boom in case interest rates cut and an increase in inflation, consistent with the empirical evidence that we discussed at the beginning of this. If you understand that part, you understand the mechanics and the intuition of the Newtonian model. Right? So then we went through a couple of numerical examples, familiarizing ourselves with the quantities, but that's basically a quantification of the real interest rate channel, qualitatively that we just we learned that the quantitative impulse responses, the red lines, are qualitatively in line with the empirical evidence, while the blue lines pertain to flexible prices. The case of flexible prices, that is not in line with the data, but it's a useful benchmark to compare against. Right? So that's basically the point. We also looked at technology shocks and learned that sticky prices do alter how technology shocks affect the economy in a qualitative way, that it leads to a dampening in output expansions and so forth. So that was a part of the course that we did yesterday. So in terms of concluding remarks, we just learned that price stickiness is the key element in this economy, in this model, right? So that's where all the action comes from, very important, and that it affects the way how we think about monetary policy affecting the economy. There are extensions, and two of them are we going to discuss in the remaining part of our course. We then launched into another slide deck that makes one more step toward you guys being able to understand, for instance, the macro climate paper, right, that I asked you to read. Okay? So here is an extension, and essentially what this extension is all about is introducing one more shock into the model and making sure you understand why, for instance, in this literature, you will often see people using a shock like this. Okay? You open any New Keynesian textbook or research paper, you will find most likely a version of this kind of environment. So what was the basic idea? Again, in macro, right, we do this two-step approach. Step one is we look at data, identify a puzzle, and then step two is we are thinking about how can we account for the features in the data. Okay? So this is the typical step one. Step one, the empirical evidence or the data. And the key element that we discussed yesterday is that when you are considering, say, a measure of inflation and a measure of the output gap. So what is this output gap, right? So the output gap is the log ratio of real GDP in the data. That's the ratio of log real divided by potential output in the data. Potential GDP. So that's what this output gap is, and CBO means it's the Congressional Budget Office, so it's a body of the US Congress. Okay? And they are estimating potential GDP in the United States. So you take a time series for real GDP, you divide that time series by potential GDP, you take the logarithm, you're going to get that blue line. Okay? That's where this data comes from. And then we learned that you can represent this in the time series fashion, the two top line graphs, but then you can also represent this in a scatter plot fashion. So the scatter plot is then just, at every point in this, every dot is just a combination of inflation and the output gap for a particular time sample. And then the basic bottom line is that in this time sample, you see that there's essentially a zero correlation between output and inflation in the data. Right? That's the key takeaway. The correlation between those objects is essentially zero. That's a big problem for the New Keynesian model that we've studied so far. It's a big problem. And the remainder of this slide deck is supposed to make clear why this is a big problem, and then how does the literature fix that problem. That's the basic idea. All right, so maybe backing up a little more carefully here. By the way, are there any questions so far? Is there anything that came up after class yesterday afternoon about what we covered yesterday? All good? So then let's motivate a little more and take a, that was a little fast yesterday. I want to make sure everybody's on board. And, we've learned that this New Keynesian paradigm of price seeking yields this Phillips curve. It turns out that that's a classic paradigm. I mean, the Phillips curve was around in monetary economics before the New Keynesian model was created. Phillips curve goes back to Lucas. It goes back to even it didn't carry that name, but it goes back to even John Maynard Keynes. Okay, a relationship that tries to think about how is inflation determined, right? And it's crucial to think about how monetary policy, for instance, affects the economy. Now the problem that we have is that the model that we've studied so far, right, is this model of inflation determination, where inflation is a function of expected future inflation and the output gap. And for simplicity, I ask you to assume, let's suppose inflation expectations are always anchored in the sense that inflation expectations don't move, just as an example. So set this expression to zero for a moment. So the resulting Phillips curve then looks like this. Right? That when you drop the expectations term, then inflation is a function of the output gap, where kappa is a positive parameter. And there you see already the big problem, right? If you now go and simulate this model, you're going to find that kappa being a positive parameter, right? That the correlation between the output gap and inflation is 1. So the correlation, let's just write this down, the correlation between inflation and output is exactly equal to 1 in this case, right? So if you take our model, the one that we just studied the last 2 days, and you simulate data from that model, right? You simulate data from that model for long periods of time, and you get artificial data from our model for inflation and the output gap, and then you do a scatter plot, you will find that the correlation in the model is 1. And that's the but of course that's exactly wrong relative to the data. The data says the correlation is 0. That's the big tension here. And that has led people to think about, well, wait a second, if the data suggests a 0 correlation, but your model has a unit correlation, it's just a bad model. That's how we in macroeconomics typically discriminate about models. Ivy has maybe her favorite model about how the world works. I have my favorite model of how the world works. And the competition is which models will say shall we work with. You go to your boss, I go to your boss, and we both propose 2 different models. And then the boss is supposed to pick which model to work with, which model to base actual monetary policy decisions on.
And the question that your boss is going to ask the two of us is, okay, show me what empirical properties does your model have? And Ivy is going to show her model version, I'm going to show mine, and then the boss is going to pick the model that fits the data best. And if I show your boss Ivy, this model with the human correlation, your boss is going to look at me and going to say, that's a problem. So you're telling me, right, this red line, you're telling me that if you're working with a Phillips curve in your model where inflation is kappa xt, Matthias, that's not really good. Because that produces this unique correlation. Ivy has a better model that produces this shotgun blast. I work with Ivy's model. And so that's typically how macro works. The better model dominates the bad models, and the bad models typically get thrown into the dustbin. So this poses a question now. What we have studied so far is this a model where we need to basically abolish working with? Shall we just stop working with that model because it produces this very strong positive correlation? Right? Or have we just overlooked something? Is there something missing from this model that we just haven't put in yet? And once we put it in, the model starts to perform better. That's the key. Now, you may ask, okay, Matthias, you made this assumption about this one. I'm going to relax that assumption in a second, of course. Okay? So we're going to show you next, when we have that term as well, we're going to still get a very positive correlation. That's just for you. Okay, so let's then, we don't need to recall this, you know these equations by heart. Okay, so those are our three equations that we've been working with so far, and there's these two shocks, right? There is the technology shock, and then there's the monetary policy shock. Those are the two shocks that this model has, and we've been working with this. Now let me do the following now. Okay? Let me single out the technology shock. So let me just single out that technology shock, and let me simulate the model for 10,000 periods, just with that technology shock. So what I do is I go and I draw a random sequence of shocks for technology, like 10,000 random observations. And then I'm going to stick those 10,000 observations into this model, period by period. So I'm simulating artificial data from this model. That's the exercise we're doing. So in Diner, you don't have to do anything. Diner does that for you. Once you hit the button in Diner and say solve, then it's going to give you automatically these long time series if you're looking in the right place. Let me show you how that looks like. So this is the simulation, a long simulation with technology shocks only. So this is when you have technology shocks only. So this is the ZT, head shocks. And I'm simulating this for 10,000 periods, but I'm displaying only 150 quarters here. Okay? So there's more data, but I'm just displaying that. That's how the model generated data would look like from this model. The top is the technology, right? And there's no other shocks. And then the model generates this artificial data, this model-based data for inflation and for the output gap and for output. I mean, all endogenous variables that we studied so far, you get artificial data. And what I'm going to do, and then when you look closely, I'm mostly interested in thinking about inflation versus the output gap, right? So that's what I'm interested in. Now, when you have sharp eyes, and you guys are still very young, see that, wait a second, when inflation drops a lot here, it turns out that the output gap also drops a lot. Okay? Or when inflation goes up a lot, the output gap goes up a lot. That already indicates, these things seem to kind of co-move very tightly. That's another way basically of saying that. When you look at the extremes, that often these things seem to move together. But we can make that, again, this is the time domain, this is the time series plot, just as you would in the data. This is the time series plot. And what I'm going to do next is I'm just going to do a scatter plot now. So I'm going to take the output gap and inflation data, and I'm going to use that, and I'm going to put that into a scatter plot. Okay? So let's use the inflation and output gap data and put that in a scatter plot. And that's what we have on the next slide. So these are the scatter plots of inflation and the output gap coming from, this and that. So let me maybe pull this down. So this is going to go there, and then this is going to go there. They go into the next slide, and then I'm just going to draw when we only have technology shocks. I take that artificial data and I have the output gap on the x-axis and inflation on the y-axis. You're going to see, the big problem that this model has, that I try to motivate, intuitively based on the Phillips curve. You see this is exactly coming out of the model. It's actually a straight line.